Today, I will walk you through how we transformed a system from an unusable state into a scalable solution. And the turning point was not query tuning, it was redesigning the architecture, then around Ignition's strengths. So the transformation was done for a client who was already operating on a legacy SCADA platform. And the system has grown over time, but the architecture had not evolved with it. And eventually, the historical reporting was unusable, as we would run a query for a single data point, data on 1 hour, and the results returned basically the next day. And what should have been a lightweight time series query was triggering full table scans and excessive resource consumption. Of course, some of the root causes that we have identified was that there was no defined polling strategy, not a standard behind the data points organization. The data itself was with very limited data access, and the entire architecture was not able to scale. But most importantly, the data acquisition, the storage, and the reporting were tightly coupled. And every heavy or not that heavy historical query directly impacted the operational performance. And the entire foundation needed to be designed. And that's exactly where Ignition became the enabler. So what you see here is the core of the solution that we used is a scale out architecture where we have the backend gateways and we have the front-end gateways. Of course, the backend gateways handle the device connection, direct PLC communication. There we have defined the tag standard and the historical data collection as next to each backend gateway. We have a Postgres server. And on the front-end gateways, we have supervision. We have, of course, the perspective sessions, and we have full dashboards and reporting. And this layered approach enabled independent scaling of each of the components. And it was very important in this scenario that each standard has a dedicated Postgres database server deployed locally on a shop floor area. And the reason behind that was operational independence. This meant that data acquisition, tag execution, and historical storage remained fully functional, even if the connection to that central front-end gateway was interrupted. If the network link, of course, between the front end and the back end was lost, the back end gateway continued communicating with the PLCs and writing the data to the local Postgres server. While this architecture that we see here on the diagram is designed for per site level, we also have an additional enterprise level where data from currently 3 sites is transmitted via MQTT to this higher level, where we have visualization for some high-level aggregated data. And that structure aligns with the UNS concept, where all site-level data is published into a centralized data layer. Okay, so for diving deeper into the backend layer, or the combination of the standard gateway and the Postgres server, here we didn't just connect the PLCs, but we engineered the data acquisition with the operational needs. And we structured the tag model using ISA 95 standard. We have definitely leveraged the utilities from Ignition, and that improved maintenance and significantly improved and optimized the historical queries. Here, it's also important to mention that leverage Ignition's built-in store and forward functionality, because if the database connection was interrupted, data was buffered locally at the gateway. And then lastly, we have a combined Postgres server with an extension of Timescale, where we leverage the use of hypertables. So on the front end, we have centralized site-level supervision without impacting the backend performance. All communication between level 1 and level 2, or the backend gateways and the front-end gateways, is done through a gateway network. This also means that each production area can operate independently and yet still contribute to that centralized view of operation between different shop floor areas. Again, the most important part is that whenever the client expands, we simply deploy an additional standard gateway and connect it to the network, and no redesign is required. So here the horizontal scaling was a key point. If we can go to the next slide, and I think the final slide. So here, or as a result, Ignition gave us the architectural flexibility to decouple, to optimize, and to scale. Now we have historical queries returning in seconds, of course, depending on time range that is selected. Then we have a system that scales as operation expand. Engineers have reliable, fast access to data, and the backend performance remains stable even after under-reporting load. Thank you.
Excellent. Thanks, Dragana. Yeah, I think that's a really incredible story to tell, that taking to scaling out those gateways can take you from a second or days down to seconds when running a query. That's awesome.